Okay, so we've been asked to prove here that this quadratic here is greater than 0 for all values of n, okay? So, you know what it looks like in terms of a graph, quadratic, it's a U shape, yeah, smiley face. And all of those values on that graph have got to be positive, okay? In other words, if we were to draw it on a x and y axis, okay, it might look something like this. Okay, whereby the curve itself, then every value on it will have positive y values. It will not cross the x-axis, okay? It will not cross it. So, if we were to solve that to equal 0, forget it, because you won't get solutions, okay? Because it never equals 0. You want it to be positive for every x value. Of course, in this case, we're referring to n, aren't we? Okay, so they haven't put it in terms of x, they put it in terms of n, but that doesn't make much difference. Now, in order to prove that it's always positive, what we can do is we can complete the square, okay? Because the good thing about completing the square is you can find what the minimum value is. Yeah, in this case, there is going to be a minimum because it's a U shape. So if we can find what the minimum is, well, if the minimum is positive, then every other value, of course, is going to be greater, so that's going to be positive. If the minimum is negative, then of course this can't be true. Okay, so let's complete the square. So remember, when you complete the square, you bracket squared, you halve this value here, okay, so because it's minus 4, half of it will be minus 2, and then you take away, then you always take away the square of this. So when you square this, you get 4, and then don't forget then to add on the 5. So this will be n minus 2 all squared, and then minus 4 plus 5 is plus 1, okay? So you can see now what our minimum value is. That's our minimum value. Our minimum value is 1, okay? So looking at this here, okay, we'd have 1 there. Everything else then is greater than that, okay? So, you might not quite get this yet, but you always got to remember that the minimum value is that there. And you can actually work out what the value of n is going to be as well. N, in that case, will be the opposite of this, which will be positive 2, okay? Okay, so that's where it occurs. So we can say minimum value of n squared minus 4n plus 5 is 1, okay? And this occurs when this bracket here is equal to 0, okay? Because that's the smallest. In fact, you can put bracket squared if you want. That's the smallest this bracket squared can be. So if you think about it, when you square something, it can't be negative, can't it? Ultimately, n minus 2 all squared has got to be greater than or equal to 0. That cannot be negative. When you square, it's never negative, it's positive. The lowest it can be is 0, okay? So if the lowest this can be is 0, then the lowest this can be is when this is 0. And of course, if this is 0, then you just get 1 at the end. So that's why we say the minimum value is 1. So it occurs when n minus 2 all squared is equal to 0. So that means, of course, n minus 2 is 0. So n is 2. Okay? But ultimately, we've shown the minimum value is 1. So we could say, look, since minimum value is 1, we could say then n squared minus 4n plus 5 will always be greater than 0 for all values n, and we've proved it.